Alright, so looking at that y equals x squared, that is your parent function for a quadratic. What is the vertex of this? 0, 0. So here in a little while, whenever we talk about right, left, up, down, okay, instead of, and know that it is the vertex, but instead of thinking about that whole parabola and all the little points that are on there, instead of thinking about that whole thing moving around, just think about that vertex moving. So if I went right 5 up 2, I go from the origin and I go right 5 up 2. There's my new vertex, and roughly there would be my new parabola. Okay, some people struggle whenever they have to move it around. Just think about, and a lot of times I will refer to it as the handle, and that's just because think about that's what you would grab to move it right 5 up 2. And the whole rest of it moves with the vertex. Okay. The quadratic function in vertex form, and this is why we have HK instead of CD. Most other units we will have CD. But it is A times B times X plus or minus H squared plus or minus K. Which we saw the vertex form last class, and it had all of this except for the B. So we're just kind of adding that in there. It is very, very unlikely that we will see problems with all of these transformations in one equation. Okay, this would be as complex as it gets. Most of the time we'll have 2 to 3. Okay, sometimes 1. So know that this is going to be as complex as it gets. If the A value is negative, does anybody remember what that does? Do what, Garrett? No. We don't want to say flip. We want to reflect it over which axis? The x-axis. And if the B is negative, then it does what? Say it again, Gracie. Reflects over the y-axis. The A value. If the A value is between 0 and 1, what did that do? It vertically what?
Compressed.
Vertically compressed. And if the A value is greater than 1, then it did what? So now going over to the B, whenever the B is between 0 and 1 or greater than 1. If B is between 0 and 1, what is that going to do? Horizontally stretch. And if B is greater than 1, horizontal compression. The H value, or again, kind of whenever we get out of, unless I'm forgetting a function that we might have H in, most of the time we will refer this to as the C value. Okay, so the C or the H, which 2 directions is that going to move it? Which 2 directions is that, Carrie? Left and right. With or opposite the sign? Opposite. The K value, which two directions is that going to move it? Up and down, with or opposite the sign? With the sign. Before we go down to the examples below, let's talk about these real quick. Okay? If you remember, whenever we talked about transformations, I referred to the things inside the parentheses. I referred to the show Stranger Things. Okay? Everything that's inside the parentheses is going to be, and if you watch the show, you might get that, you might not. I don't know. Everything inside the parentheses is going to be opposite of what you would think it would do. Everything outside the parentheses is going to do what common sense would tell you it would do. Okay, so first, kind of comparing the A and the B value. The A value, if it's between 0 and 1, so it's a smaller number, it's going to compress it. It's going to shrink it. Whereas if the B value is between 0 and 1, it's going to stretch it. It's going to make it bigger. So that might be opposite of what you would think it would do. If A is greater than 1, it's a bigger number, it's going to stretch it. Whereas if B is a bigger number, it's going to compress it. Looking at the H and the K. So the H is inside the parentheses, so it's going to be opposite the sign. Alright, if it was plus 3, a lot of people would probably originally think it's going to go to the right 3, but it's going to go to the left. It's going to be opposite the sign. Whereas the K value is outside. If the K value is plus 3, it's going to go up 3. All right. You also need to know everything that is inside the parentheses. And whenever we did the little move the monster thing a while back, we talked about this. Everything inside the parentheses, is that going to affect the X values or the Y values? The X values. Okay? Left and right. Sorry. Yeah. Horizontal stretch. Horizontally is left and right. So the X values are changing. The H value moves the whole thing to the left and right. So that's changing it. If it's negative, it reflects across the Y-axis. So the X value is changing. And then everything outside the parentheses is going to be affecting the Y values. That's what's going to be changing there. Okay. So let's go down. We're just going to look at these examples. Identify what transformations are happening and just writing them in words. All right. So looking at number 1. Josh, what transformation is happening? Do what? So on number 1, which one of those transformations that we just talked about? So is that 3/4? Is that the A, or is that an A or a B value? An A. And so it would be vertically what? So vertically compressed by 3/4. Okay. Going over to number 2, Garrett, what transformation is happening there? How is it moving?
Oh, no, the -5.
What is that?
5.
So what is that doing?
Going down 5.
Down 5. Okay. Know the difference as to where is the squared, and it, as opposed to the left, right, up, down. And I think some confusion happens is whenever I just wrote that really long, the thing with the A, the B, the H, the K, that whole thing, we go from that, which I said that was the most complex that you would ever see, to the point where we probably won't see all of that in one equation, to something that is simple like this. So that almost makes this hard because we were just looking at something so complex. All right? Don't get this confused with right 5. If it was right 5, it would have to be like that. Okay, the h is always, the left and right is always inside a set of parentheses. Number 3, Aiden, what is that doing?
It's reflected over the x-axis.
Reflect over the x-axis. On number 4, Isaac, what's that doing? The right 4. Chance, number 5. Is that the A? Is that an A or a B value? Okay. So it's going to be horizontally. Right. Now on the number that you'll put with this, the B value, and again it's inside the parentheses, so it's always kind of weird. Whenever it's horizontally compressed or stretched, it's always going to be by the reciprocal of whatever that number is. So what would the reciprocal of 2 be? 1/2. So it's horizontally compressed by 1/2. Ty, number 6, what would that do?
Vertical stretch plus U.
Zoe, number 7.
It will go to the right, no, to the left.
Is it in parentheses?
Oh, no,
So is it
to the right.
no,
Down.
up to? Okay, looking at 8, Trey. Reflect over the y-axis. Number 9, Morgan. Gracie, number 10. Is it an A or a B, the 1/2?
A.
Is it inside parentheses or outside?
Outside.
The 1/2?
Inside.
Inside the parentheses. So it's a B, so it's horizontal. By what? Remember what we have to do with those. By 2. Questions on any of those? Awesome. All right, turn it over. On the back, we're going to look at a couple of examples that have multiple transformations. Okay, so looking at number 1. Andy, give me one transformation that's happening there.
Vertically compressed by 2.
Vertically stretched. And we'll talk about that because I think I know what you're looking at there whenever we're done with all these. Joe, give me another transformation on number 1.
Went down 3.
Okay. Rose, what does the x minus 6 do?
I mean x plus 6.
X plus 6, sorry.
Makes it go left 6.
Awesome. And Marsha, what does the negative do?
Reflected over the x.
Alright, I want to talk about something that Andy said, and it's a common mistake. Whenever that 2, or whenever that A value is negative, make sure that you see this as 2 different transformations. Okay, the negative reflects it, and then you go to the 2. 2 is greater than 1, so it's vertical stretch. For it to be compressed, you're not looking for less than 1. You're looking for between 0 and 1. Okay, so the negative will never come into play on the vertical stretch and compress. Going to number 2. Zach, give me one transformation that's on there.
Right 3.
Okay. Chance, give me another one. Tell me what that 1/2 does.
It horizontally compresses or stretches it by 2.
Horizontally stretched by 2. And Jonathan, the +2 at the end, which direction does that move it?
To the right.
Up 2. Okay. The next 2, it's the same idea, just in reverse order. It's going to give us the transformation, and it wants us to write the equations. Okay. So you don't necessarily have to write this next part that I'm going to write, because I'm going to end up erasing a lot of it and replacing it with the numbers that we need to put in there. This right here? It would be a good idea. So first it says vertically stretched. So Pauline, a vertical stretch, is that the A or the B? The A. Okay. And then it says vertically stretched by 3, so I'm going to put 3 in there for A. After that it says it reflects over the x-axis. So Aaron, does my A or my B need to be negative?
Wait, what'd you say before that?
It reflects over the x-axis. So does the 3, the A value up there, or does the B need to be negative if it reflects over the A? After that it goes left 2. So Morgan, what does my H value need to be? +2. And then it says it goes up 2. So Lily, what does the K value need to be? +2. Alright, now, since there is no B value, what that equation would look like is this right here. There is no B value, you're just going to have the one set of parentheses. So number 1. Aiden, it says that it is horizontally stretched. So horizontal stretch, is that the A or the B?
That would be
B, because it's horizontal. And if it's horizontally stretched by 2, what needs to go in the equation? 1/2.
What's the reciprocal of 3?
1/3.
What's the reciprocal of 4?
1/4.
What's the reciprocal of 1?
Alright, so looking at, then it says it reflects over the x-axis. Okay, so Gavin, if it reflects over the x-axis, does my A or my B value need to be negative? A. Then it goes to the right 5 units, so Garrett, what does my H value need to be?
x minus 5. So it goes to the right.
Yes, sir. And Ryan, it goes down 6, so the K is.
-6.
And then if you wrote this out, if you saw it, that A value, that A would not be there, so that's what the equation would look like. Questions on that? All right, let's go to 3 and 4. So looking at tables and finding the transformations. Okay, on 3, we're going to put those transformations into words. On 4, we're going to write it in what's called f of x form. Okay, so first let's look at 3. So the first thing you need to look at is, and one thing that will help is be able to find the vertex from a table. So on f of x in 3, what would my vertex be? And if it helps you, you're going to find it the exact same way we found the vertex on an absolute value.
1, 0.
0, 1. So you're looking for the y value that has the same number above it and below it. Okay. And then so on this other one, it would be that right there. Now, looking at these, you need to compare the x values in f of x to the x values in g of x and look to see how they're changing. So, how are the x values changing from the first table to the second table? Do what?
The x value?
Yep.
Oh, +1.
They're all going up 1. And by comparing them, I mean looking at the first x value and comparing it to that one. 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 They're all going up by 1. Okay? So all the x values, if they're going up by 1 on the x-axis, which direction is that going? To the right. All of the y values are doing what? Going down by 1. Okay. Going to 4. What are the x values doing? X's are the same. What about the y values? Now -1. And some of these can be tricky, especially whenever this transformation is on here. And if you can, and it's for a lot of people, it's pretty hard to look at a table and be able to see the parabola. So if I have 1, 8, 2, 2, 5, 3, 4, 4, 5 for f of x, and g of x, I have 1, -7, 2, -4, 3, -3, and 4, -4. So what is one of the transformations that happens with the y? They do what? They reflect. So the y's reflect. And they also do what? Because if 8 reflected, it'd be at -8. But this is saying it's at -7. So it reflected and it also did what? Went up by 1. Okay? Sometimes those can be kind of difficult to see without doing a rough sketch. Okay? Now we're going to take these, which we put into words, we're going to put it into what is called this f of x form. Okay? In this form, it can cause some confusion for some people. So we're in this f of x form, we're doing the same thing, but it's just kind of a shorthand instead of writing it in words. And we're going from f of x to g of x. So whichever one you're going to, that's what you're going to set it equal to. So g of x equals whatever the end result is, that's what it's going to be. You're going to start the equation off with. So I can take, to get to g of x, I can take f of x and do what two things to it? Reflect it over the x-axis and move it up 1. Okay? That right there is completely different than that. It is not the same thing. Okay? If you're writing it in f of x form, you will not have the squared on there. Okay? Now, don't make the changes that I'm about to make changes on here. But if that same equation, let's say that it also went to the right 5. So I would have room in my parentheses and I would put minus 5. No, do not write that in there. Because I want you to have the answer, the correct answer to what was the problem had. Let's say we also notice that all the y values also doubled. So I would have an a value right there. Okay, so all those transformations, if you were to read this and list, let's say I gave you this instead of an actual quadratic equation and said, what are the transformations? It's all the same stuff. Reflect over the x-axis, vertical stretch by 2, right 5 plus 1. That f is not doing anything. I had a lot of people in first period trying to figure out what the f did, what transformation it did. It does not do anything. Okay, so don't freak out and think that it does. All right. Any questions on that?